Hello and welcome to Today I Learned Climate. I'm your host, Laur Hesse of the MIT Environmental Solutions Initiative. We often hear about recycling as a way to make an impact on climate change right in our own homes. But how big of a difference are we really making when we recycle? We talked to a recycling expert to help us understand if recycling is really a climate solution.
My name is Damgaard, and I'm a senior researcher at the Technical University of Denmark, where I'm sitting at an institute called the Department of Environmental and Resource Engineering.
Professor Damgaard has been studying recycling and waste management for his entire career. So let's start with the basics. Why bother recycling at all?
For pretty much any material, the recyclable materials are much cheaper to reprocess than the virgin materials. And this is the main reason why we do recycling. Let's take the aluminum can, because it's a perfect example. So when we make aluminum from raw materials, we start with bauxite ore. Then we go through a heavy purification of that and grinding up to alumina powder, which we then have to turn into aluminum, which requires insane amounts of electricity.
And all that digging, grinding, and refining is powered mostly by fossil fuels, which emit carbon dioxide and other climate pollution when we burn them. But we can skip all of that if we instead start with recycled cans.
They are already aluminum, so we basically just have to remelt them. And therefore, when we look at an aluminum can from recycled material, it probably have used somewhere like 4 to 5% of the same amount of energy it took to create it the first time from raw material. So, we save 20 times the emissions of starting from the raw materials.
Whoa, let's repeat that. We save 20 times the emissions and 95% of the energy by making aluminum cans out of recycled aluminum. And those energy savings also translate into cost savings for manufacturers. So recycled aluminum can be sold at a nice profit, which means there's a real business here. But the climate benefit of recycling really depends on the material.
There's sort of two things we go for. Things like tin cans and the aluminum can we just talked about, which is maybe making up 1 or 2% of our overall waste amount, which is not a lot, but which has a very high environmental sort of value carried with it from the production. And therefore, even if it's small amount, recycling makes a lot of sense. But then we have the other end, which is things like paper and cardboard, which maybe on a per pound basis is not giving that big an environmental benefit, but because we recycle so much of it, we get large quantities, which means there's economies of scale in doing it, and there's environment of scale in doing it.
Here in the US, we throw out over 65 million tons of paper a year and recycle about 70% of it into new paper products. Remember, paper is made from trees, and trees store massive amounts of carbon from the atmosphere. So when we recycle so much paper and use that to make new paper products, that's a lot of trees that aren't being cut down. The U.S. Environmental Protection Agency, known as the EPA, analyzes the environmental benefits of recycling. And they found that almost all, 95% of the climate benefits of recycling comes from recycling just paper, cardboard, and metal. This was really surprising to me because when I think about recycling, I largely think about plastic. But in 2018, which is the last year that the EPA has data, less than 10% of plastic was recycled. Why?
Plastic is a complex material. There's probably more than 10,000 types of plastics on the market.
You know those little recycling numbers on a plastic package in that triangle with those arrows around it? They tell us what kind of basic building block, or polymer, a plastic is made of. Like a plastic bag is made of a different polymer than the plastic bumper of your car. But while there are only 7 of these recycling numbers, in practice, there are way more than 7 kinds of plastic out there.
When we make a product with plastics, we put in our polymer and then we start putting in additives. And we put in additives to get different functionalities, different colors, different stiffness and hardness. And that's often the big challenge we have actually, is figuring out what is in this plastics.
And some of these additives, like heavy metals and older plastic PVC pipes, are really dangerous. This all makes recycling plastic challenging because the workers and machines at recycling centers have to sort out all the different types of plastics. And more additives means more different types of plastic. If these recycled plastics are not perfectly sorted, they're considered impure or contaminated, and companies are generally less willing to buy them. That's what happened in 2018 on a global scale. Until recently, 70% of plastic recycled in the US and 95% in the European Union was sold to recyclers in China, who use the plastic to make new products. But in 2018, China started only buying plastic recyclables with almost no impurities. Since then, hundreds of cities all over America have stopped recycling some or all types of plastic, unable to sell what they were collecting. Okay, but even if recyclables were perfectly sorted, the business of recycling itself does produce climate pollution.
There's pretty much emissions for everything, right? The collection vehicles that will pick up the recyclables, we're burning diesel or natural gas, and we use a lot of different machines to sort the different types of materials, and they all consume electricity.
And after we collect and sort the recyclables, we have to turn them back into raw materials.
And of course, here we use huge quantities of energy, but we also have emissions coming from the materials, impurities, etc., being released. And this is definitely where the biggest impact from the recycling chains come.
With a material like aluminum or steel, recycling saves way more emissions than it adds, as we covered in the beginning of the episode. But with something like glass, it's not so clear-cut.
For glass, recycling is quite small environmental benefit. So if you are out in smaller cities where there's not glass manufacturing nearby, and we start to move a material that's very heavy, and if it then costs a lot of dollars to transport it to a place where we can recycle it, we might end up saying, okay, we would rather spend that somewhere where we get more environmental benefit for the money.
Which is why many cities and countries are trying to switch the focus. Instead of trying to recycle whatever we put in our bins, they're trying to change the very way we design and dispose of products, so it's easy to use all our materials over and over again. For example, take something called deposit return systems. They're common in Europe and in some American states. You pay 5 or 10 cents extra for, say, a can of soda, and then get that money back when you return the can at the grocery store.
So there is a fiscal incentive to get these materials returned. And what we see, at least in the countries in Europe that have this, we have very high recycling rates for deposit return systems. So in Denmark, the return rate in average across these different types of bottles of different materials is 93%.
These deposit return systems have even nudged manufacturers to make their products easier to recycle.
In the Danish case, the cost of operating the deposit return system is actually coming from the producers of the goods. If you want to sell your product on the market, you have to pay into the system. And if you come with a really terrible material, you will have to pay a much higher price than if you pick a material that's easy to recycle.
And a lot of new recycling policies are trying to incentivize companies to make their products out of recyclable and recycled materials. Take something the European Union will roll out in 2025. It's called Extended Producer Responsibility.
Which is that basically the people that produce the materials that becomes waste have the fiscal responsibility to ensure that they're being recycled, meaning producers that put a glass container on the market, they need to make sure it's being recycled into a new material. Probably what will happen is these companies will then form associations that will say, okay, now it's collected. We will take over the material probably at a cost, and then we will make sure that it's recycled into new material.
Or you can do what the United Kingdom does, tax new plastic. After all, we as taxpayers have to pay for unrecycled waste to go into a landfill. A tax can make manufacturers pay for some of that cost.
So there's a fee being put on most of the materials if it's made from virgin material, where there's no fee if it's from recycled material. So that actually means the higher recycled content you have in the material, the less you have to pay in fees.
So let's say the world made a significant effort to expand recycling, making more products recyclable and actually recycling them. Would that make a significant difference for climate change? The short answer is, well, yeah. Project Drawdown, an organization that analyzes climate change solutions, estimates that between 2020 and 2050, if we improved recycling systems worldwide and recycled a healthy majority of the materials that we consume, the world could save around 11 gigatons of carbon dioxide. That is approximately equivalent to the 2020 CO2 emissions of the United Kingdom every year for 30 years. So, bottom line, yeah, recycling can make a dent on climate change. But for tough materials like plastic, recycling as we know it today isn't delivering those climate benefits. To see real climate benefits too, we'll need bigger changes to how products are designed. And we might want to look at how much waste we're creating in the first place.
What we should always start with is prevention to avoid using materials. So it's just important when we talk recycling, especially when we also talk design, if we can design for reuse solutions, that's of course better than going straight to recycling. Now we have to relearn ourselves that any material actually have a value, and we have to appreciate that both from a fiscal point of view, but also from an environmental point of view.
That's the end of our episode and of this season of Today I Learned Climate. But we will be back, so stay tuned to this channel for an announcement about Season 5 later this year. You can also go to tilclimate.mit.edu and look at our show notes for more information about recycling and to see our educator guide on this episode, which includes an engineering and design challenge for the classroom. TAO Climate is produced by the MIT Environmental Solutions Initiative at the Massachusetts Institute of Technology, where we're tackling the plastics recycling problem. Go to environmentalsolutions.mit.edu/plastics to learn more. David Lishansky is TAO Climate's editor and producer. Aaron Krol is our associate producer and did our artwork. Natalie Jones was a scriptwriter for this episode. Michelle Harris is our fact checker. Sylvia Scharf is our climate education specialist. Ilana Hirschfeld is our communications production assistant. The music is by Blue Dot Sessions, and I'm your host and producer, Laur Hesse Fischer. Thank you to Professor Damgaard for speaking with us, and thank you for listening.